Hello everyone, welcome back to lecture 26. This is part 2 of lecture 26. So, we will continue our discussion on the glacial lake vulnerability assessment. So, when we talk about the lake assessment, we have to go for the hazard assessment. This involves identifying and characterizing the potential for GLOFs, including factors like volume, dam type, the moraine ice, and potential triggering mechanism like earthquake, avalanche or any other activities, right. So, then we go for the vulnerability assessment. This evaluates the sensitivity of exposed area to GLOF impacts, considering factors like the presence of critical infrastructure, population density and adaptive capacity. Then comes the risk assessment. So, this combines hazard, exposure and vulnerability assessment, right. So, I will have a few more explanation to understand this risk, hazard and vulnerability. Then comes the mitigation and adaptation strategies. So, based on the risk assessment, strategies are developed to reduce the likelihood and impacts of GLOF, including early warning system, infrastructure protection and community preparedness, right. So, this particular slide is meant to explain the risk, hazard, exposure and vulnerability. Now, you just try to listen this and follow this image. So, the flood represents the hazard, right. So, here we have the flood, right. So, this represents the hazard, while exposure is shown as the area submerged by the water. So, this area which is submerged, that is the exposure. Vulnerability extend to the larger population that may be affected. Although the flood has a defined physical boundary, its consequences can reach well beyond that limit, right. So, I hope it is clear: risk, hazard, exposure and vulnerability, right. So, here the potential source of harm like GLOF and avalanche, that will be your hazard. So, when we talk about risk, it is the probability of the hazard to cause harm or damage that will affect the surrounding and environment. It can be people or it can be environment or both. So, here you can see the risk. When we talk about risk, we have to go for the vulnerability assessment, exposure assessment and the hazard analysis. And the real time observation, we have the remote sensing data, meteorological data and hydrological data that is needed to go for the real time observation. The susceptibility mapping has the identification of high risk zone, the modeling and simulation, that will be likelihood of the event and the severity of the event, right. So, let us try the risk. Risk is the probability of a loss that depends on hazard, vulnerability and exposure, right. The most common definition of risk is the combination of flood hazard and flood vulnerability at a given location. So, risk will be hazard multiplied with vulnerability. Risk assessment analysis aim to minimize the possibility of the GLOF event. When we talk about hazard, it refers to a process or phenomena that may cause disruption or damage or loss of life. Whether something is a hazard or not depends on the probability that an event will occur and its expected magnitude. For example, a dormant volcano has a very low hazard as the probability of eruption is near 0. Given that the same type of hazard can have different probability and magnitude, we often scale our hazard referring to them as low or high hazard. Now, we have the vulnerability. In simple term, it is the extent of harm that may occur to the elements exposed to the hazardous event, right. So, the vulnerability will be exposure plus susceptibility and that will be subtracting resilience. It varies with the element under consideration. For example, physical vulnerability for physical element such as houses, road, infrastructure, etc. Other type of vulnerability are social and economic vulnerability related to society and the economy of that particular region or a country, right. Vulnerability as a condition influenced by various factors such as ecological, social, physical and economic, and increases people's susceptibility to hazard impact, right. Now, let us talk about the exposure. Exposure is the presence of vulnerable elements within the extent of flood inundation. It is assessed based on inventory of anthropogenic elements such as village, road, bridges, hydropower station, etc. that may be affected by the hazard. It refers to the likely economic, social and cultural human impact of the hazard. For example, this can include people, livelihoods, service and resources, infrastructure in that particular area. To quantify exposure, the information such as population density or the count, number and types of houses, number of bridges, area of agriculture land and other infrastructure or activity of economic value must be collected within the likely hazard zones, right. So, the GLOF risk is usually defined as a function of hazard, exposure and vulnerability, and here you can see this is the reason where we have the risk, right. So, for that hazard, exposure and vulnerability has been done. So, GLOF risk will be equal to hazard multiplied with exposure multiplied with vulnerability. So, this diagram shows the glacial lake outburst flood risk. Risk is a combination of physical hazard including the potential outburst magnitude, downstream exposure and social vulnerability. So, here these are the different factors contributing to the glacial lake hazard. So, the first one is the lake volume, then seismic activities, instability of moraine dams, glacial retreats, heavy rainfall or snowfall, human activities like mining, construction, road construction, bridges construction, avalanches and stagnant glacier ice within dams, right. So, the importance can be understood here. The early warning system, the GLOF vulnerability analysis helps to identify areas at high risk and develop early warning system to provide timely alert to populations. Infrastructure protection, that is another aspect. Vulnerability analysis can inform the design and location of infrastructure to minimize GLOF impact, right. Then community preparedness, the people residing in that particular area, they will be prepared what to do, what not to do during a catastrophic event. Risk reduction strategies. So, vulnerability analysis provides a basis for developing and implementing GLOF risk reduction strategies such as dam stabilization, drainage improvement and climate change adaptation measures. So, here you can see the key aspects of glacial lake vulnerability analysis. So, here you have identification of the potential dangerous lake, GLOF simulation, impact assessment, risk mapping and then mitigation strategies. Lakes are recognized by lake size, depth and dam stability. Hydrodynamic model simulates breach of lake dams. GLOF impacts on infrastructure, settlement and population that can be studied. Vulnerability assessment results as a risk map. Risk map delineates area that is more at risk. Based on the vulnerability assessment, mitigation strategies could be planned. So, the vulnerability assessment, it can be measured and quantified with the help of various indicators by estimating the exposure, sensitivity and adaptive capacity respectively. Quantifying the vulnerability of a system to any specific natural hazard or climate change is known as the vulnerability assessment technique, right. So, here you have exposure vulnerability index, sensitivity vulnerability index, adaptive capacity vulnerability index, composite vulnerability index. These can be used to assess the vulnerability of a glacial lake. So, what are the different causes of the glacial lake outburst flood? So, here we have a list: glacier retreat due to climate change, glacier moraine failure, avalanche, then glacial lake overtopping, landslides, human activities, glacial lake expansion, glacial surging, earthquakes, geothermal activities, extreme weather conditions, then glacial calving. So, these all can lead to the glacial lake outburst floods. So, here you can see this is one example from the Sikkim Himalayas, where we have conducted several field investigation. So, with the aim to identify potential glacial lakes susceptible to future GLOF event, lakes with aerial coverage of more than 0.01 kilometer square have been considered for the vulnerability assessment, right. So, to start with, we have used the remote sensing data set, and then we did the change analysis for the glacial lake boundary, and then we found that some of the lakes have been vanished, some of the lakes are drastically increasing in their sizes, and some of them are in the original condition, right. So, this analysis helps you to prioritize which glacial lake needs to be continuously monitored for any future hazard. The seismicity we have included in our analysis, because this is one of the important aspect. This can trigger the GLOF event. So, the northeastern Himalayan region experience seismic tremors very frequently. The glacier bodies lies close to MCT and other tectonic features. There has been a record of 179 distributed earthquake events in the area with magnitude greater than 4. So, here you can see the glacial lakes are represented here in the blue color, right, and the star marks are basically the epicenter. So, this is the field investigation conducted in different parts of the Sikkim Himalayas. So, it is from one of the field investigation where we have trekked for 96 kilometer to collect the in situ data sets, and these are some of the photographs from the field that you will be able to understand how a glacial lakes look like in the field or in nature, right. So, this is the calving zone, you can see. This is from another location, it is from Rathong glacial snout. So, here you can see he is standing on the glacial lake, because we visited this during the winter and this is frozen, right, the surface is frozen. Here you can see the metamorphosed glacial ice outcrops. We have also collected the moraine sample to analyze the stability, right. So, I have put a few more photographs here. So, I hope these photographs will help you to understand what is the scale of glacial lakes that we are talking about and how they look like in the field. So, you just see the photographs, this is the downstream of the glacial lake, right. So, this is the connection with the fluvial system. So, here you can see how the water is flowing. This is the glacial lake we are talking about. This is the inflow, right. So, this is from where we are getting the water into this. So, it has a connection from here, and then there is another source that in another photograph you will be able to understand. So, yeah, this is another side of this lake from where we are getting, and here we have the glaciers, right. And we have also conducted a few geophysical testing, so that we will understand the stability of the glacial lakes. This is top of that. So, here you can see this is the glacier, the main body, and here the water is flowing through this, right. So, the melt water is entering into this lake, and this is the moraine, the glacier moraine. This is from another location, this is Guru Dongmar Lake. So, based on our field investigation and the literature review and the remote sensing data products, we have formalized this analysis. So, to identify the vulnerable glacial lakes, we have considered different parameters which are listed here. You can see, and why we have listed, that is also explained in this. Then based on the pairwise comparison matrix with weight of factors, and we have ranked the different parameters, and then we have identified their weightage into our analysis. Based on that, we have identified different types of glacial lakes which are highly vulnerable, moderately vulnerable, safe, right. So, here you can see one of the lake, just see this one, it is coming moderately vulnerable, and I will try to show you the field photograph of this. So, here since we have visited during the winter, this looks dry, but in the summer season this will be completely filled with the water. So, it has been observed that 8 glacial lakes are highly vulnerable to future event. These lakes are moraine dammed lakes, and their aerial coverage as well as the volumetric capacity have been increased rapidly in the last few decades. 11 glacial lakes are classified as moderately vulnerable and should also be checked for a GLOF event, as they might become vulnerable to the near future due to the glacier melting, right. So, here you can see the results. Then comes the GLOF modeling. So, here you can see this particular video. This video is from the GLOF modeling, where we have simulated after a GLOF event how the lower reaches or the low lying areas will receive the water, and what will be the impact and how much area will be covered with the GLOF or the catastrophic event, right. Using this same hydrodynamic modeling, we have also identified the depth map and velocity map that will help you to understand what will be the impact of a GLOF event in the downstream. So, these are the two papers that you can refer, and it is an extensive paper where we have explained the different processes, different methods associated with glacial lake outburst flood, and we have also explained the vulnerability risk part. So, these are the references that we have used in this particular lecture. Thank you very much.